Hello everyone, I am a member from Team 11. My team consists of 4 members and today our team are going to introduce you to the strongest acid in the world. It's Fluoroantimonic Acid.
Referring to strong acid, many of you will probably immediately think of sulfuric acid H2SO4, an acid that is able to corrode many metals such as iron and aluminum, even when diluted, and will be very dangerous if it is concentrated. However, compared to the strongest acid in the world, fluoroantimonic acid, it is nothing. Currently, the lowest acidity known to man is minus 31.3, and it belongs to fluoroantimonic acid. That also means fluoroantimonic acid is the strongest acid in the world today. It's called super acid by chemists because of its strong acidity that no other acid can match.
What is fluoroantimonic acid? Fluoroantimonic acid is the world's strongest superacid with the chemical formula H2FSBF6. This is an extremely strong acid with all the conditions to be a superacid. The Hammett acidity function has been measured for different ranges between 8F SBF5. Normally, the H0 of 8F is minus 15, but if you add 1 mole percent SBF5, the H0 now drops to about minus 20. This addition of SBF5 causes the acidity to drop quickly, with H0 reaching minus 21 when at 10 mole percent SBF5. Reaction of fluoroantimonic acid. Fluoroantimonic acid is decomposed by heat when heated to 40 degrees Celsius to produce free hydrogen fluoride gas and liquid antimony pentafluoride. The reaction is extemic. Fluoroantimonic acid is a highly corrosive, toxic, and moisture-sensitive acid. Therefore, like other strong acids, the solvent of fluoroantimonic acid can only be hydrofluoric acid because it can react violently with water due to extemic hydration.
Why is fluoroantimonic acid the strongest acid in the world? Based on the scale of H0 value, fluoroantimonic acid is the strongest superacid. This fluoroantimonic acid is often said to contain pair protons, but the truth is that free protons are always associated with hydrogen fluoride molecules. Protons can easily move through solutions and switch from H2F to HF in the presence of the Rorschach mechanism. The hydrogen ion proton attaches to the fluorine through a very weak dipole bond, allowing the proton to move between the anion cluster and giving rise to the strong acidity of fluoroantimonic acid. How to produce fluoroantimonic acid? The canonical compound of fluoroantimonic acid is produced using antimony pentafluoride SPF 5 to treat hydrogen fluoride SF in a stoichiometric ratio of 1:2.
Dangerous levels of fluoroantimonic acid. Compared to 100% concentrated sulfuric acid, fluoroantimonic acid is 10 million billion times stronger. It is an acid with a high glutamic acid content value of -31.3, which can melt most organic compounds, including the human body, as well as glass and many other materials. Fluoroantimonic acid is so strong that it can melt the bone in it. If humans or other animals fall into fluoroantimonic acid, the consequence will be terrifying because the fluorine atom in fluoroantimonic acid tend to prefer to bind with calcium. After destroying tissue in the skin and muscles, fluoroantimonic acid will continue to burn through the bones. In addition, heating fluoroantimonic acid is also very dangerous because it decomposes into toxic fluorine gas. Fluoroantimonic acid is so strong it can melt ore, and fluoroantimonic acid can melt most organic compounds. Application of fluoroantimonic acid in practice. Fluoroantimonic acid can form nearly all organic compounds and often cause dehydrogenation or dehydration. Therefore, it is often used in chemical engineering and organic chemistry to produce organic compounds without having to depend on solvents. In 1967, Baker and Hochschiffen discovered that fluoroantimonic acid was capable of removing hydrogen from isobutane and methane from neopentane to form carbonium ions. Fluoroantimonic acid is also used in the production of gold tetraxenone compounds, materials compatible with fluoroantimonic acid as solvents including SO2ClF and sulfur dioxide. Besides, fluoroantimonic acid is also used as a catalyst for alkylation and acylation in the petrochemical field. It is also used for the synthesis and characterization of carbon cations.
How to store fluoroantimonic acid? The only preservation method is to store it in a container with a synthetic polymer, polytetrafluoroethylene, PTFE, also known as Teflon, because this polymer is made up of carbon-fluorine bonds. This is the strongest type of inorganic single bond in chemistry, especially when working with fluoroantimonic acid. Wearing protective gear is a must because this acid can corrode bonds and react violently with water in the human body.